Hello everyone. Let's continue with tutorial number 6. A sample with size 10 has taken from a population which follows a normal distribution. So here we have 10 number of data as our sample, not population. We should be careful. So the data that you can see here is related to your sample. So estimate the population mean. What does it mean? It means that provide the point estimator for the population mean, which is X bar. So when you want to provide the answer in the exam, provide the formula, like X bar is equal to, then you know the formula. Then assign the values like 65 plus 40 plus 3 dots. If there are so many data, even for 10 numbers, doesn't matter. Just 65 plus 40 plus 3 dots plus 35 to show us the trend, dividing by the number of data that you have in your sample or sample size, which is 10. So you write the formula, X bar is equal to sigma xi dividing by n, and you write, they assign the numbers, and the final answer you provide, which is 54. I don't provide them here because they are very easy and you know how to deal with that. But don't forget, in the exam, please provide the formulas completely. So estimate the population variance. How to do that? Point estimator of the population variance, which is S power 2, right? We should use a statistic. S power 2, you know the formula from the lecture. So this is, actually it has 1 over n minus 1, not capital N, but lowercase n. Take a look in the lecture and you will see. And this is important because some students forget to use n minus 1 for this formula. So provide the formula and find the final answer using the data. And what about standard deviation? You just get a square root of the variance. And what about finding the median of the sample? Okay, for this one, this is new. Let me talk about it in more details, specifically when we talk about the box and whisker plot. So for median, what we should do is to order these data. So from the smallest value, 35, going to the maximum value, which is 95. So here we have 10 as the size of your data. It means that this is an even number, so you will have 2 numbers in the middle. So 5th position and 6th position. 40 is the 5th position, 1, 2, 3, 4, 5, and here is the 6th position. So 40 plus 45 divided by 2, which is 42.5. What about the mode of the sample? Mode of the sample is the most frequent data, which is 40. 3 times you can see it happen, so 40 is the mode of this sample. Now, this part, which we will talk about in details, and this is the first time you are seeing this, so it's very important to pay attention to this part. How to illustrate the data using box and whisker plot, which shows the outliers, okay? Which shows the outliers, it means that minimum and maximum shouldn't be the tail of your box plot. Now, let's see how we can draw this one. First thing to do, this part is actually not that much related to your box plot, but anyway, it's nice to show it. So range of your data is maximum value of your data minus minimum of that. So 95 minus 35, which is 60. And this is different with your interquartile range, which we should calculate to be used inside your Viscam box plot. Okay, so let's see how we can calculate the quartiles. First quartile, Q1, is calculated by this. First, find the position. So n plus 1 over 4, because 25% of data should be less than that. So we are looking for this position. So this TH that you can see here, it shows the position, like 4th position, 5th position, and so on. So n is the sample size. 10 plus 1, 11 over 4, and it means that 2.75 position. If this number was an integer, like let's say it was the third position, so third position would be 40. So 40 would be Q1. Directly you could find the final answer, right? But now we have decimal points here, so it's not as easy as that, so we should estimate it. How to estimate it accurately? So first check 2.75, it's between the second and third position. Okay, so 35 and 40. So first write the smaller number, 35, plus the difference between these two, 40 minus 35, multiply it by 75%. Why 75%? Because here in our, after our decimal point, here we have 75. Okay, so that's how I can accurately calculate it. So we are going to use the same method in the exam. So if it was an integer, directly I could find it from our data. If, for example, it was the first position, okay, 35. If it was 3, then third one. If it is 2.75, then I should use this approximation. So you will find out that Q1 is equal to 38.75. So when students get excited when they find the position and they just say this is the final answer for Q1. No, this is just the position. You are already ordered your data, you see. If you just check the positions based on that, you will provide the wrong answer. Whenever we talk about median quartiles in general, then you should order your data first. You see, anytime I want to read the final answer, I check out the data related to the order data. So first, second, third, fourth, until the 10th position are obvious here. So what about median? Now median, I've showed you how we can find it, but for smaller sizes like 10 size, for example, is okay, you can use that method. But what if there are large number of data? Then this way is preferred. Okay, so Q2, which is equal to median, can be calculated by using this formula. N plus 1 over 2, and you find the position. So 11 over 2, which is 5.5 position. So it means that between 5th and 6th position, so of course you already know the average of them could be the final answer, and I talked about it, but let's use the same method. You write the smaller number, 40, find the difference, which is 5, multiplied by whatever extra you have after your decimal point. You see, it is 0.5, so you write 0.5. And you find your median like this. For your third quartile, this is the formula. 3 over 4 multiply n plus 1. Because we are looking for a value which 75% of data is less than that value. So assign 10 instead of n, and you will find out that 8.25 position. So it means that between 8th and 9th position. So 70 and 75 we are talking about. So first write 70, the smaller value. Here the difference of 75 and 70, and multiplied by the extra value that you can see after the decimal point here. So 0.25. You see, that's the best way to approximate it. So you have found Q1, Q2, and Q3. What do they mean? It means that, for example, 25% of your data for sure is less than this value, okay? So you may say, why we do that? Because the values that we can see here, all of them are integers. Because we are at the end trying to understand about population. So all of them could be used also as an approximation of the population. What's possibly going on in there? So using such decimal points can be useful to have better understanding. So when I can approximate it like 38.75, it means that 25% of my data most probably is less than that, but in case of my sample, we say for sure. In our sample, for sure, but this is an approximation for population. Okay, for interquartile range, this is the formula. So provide us the formula in the exam, and also for all the quartiles, don't forget to provide everything, a complete solution. Everything should be along with the formula. Okay, so Q3 and Q1, we have already calculated them, so you can just find the subtraction here, the difference between them, and 32.5 is the interquartile range. If you put absolute value here, doesn't matter, because if you put Q3 before Q1, as you can see, you will find the positive answer, which is the range. The range should be always a positive number for either related to interquartile or in general. All the time we are talking about the distance, okay? So we are talking about a positive number. Now, what about the lower bound or upper bound of the box and whisker plot? In some books, they call it the whiskers. In some books, they call them the tails, or you can also call them lower bound and upper bound. So in order to do that, I told you I will give you the formula. So in the exam, please use the same formula like this. Q1 minus half interquartile range. In different books, maybe they use different multiplication, but now we are fixing it together today that this should be used for our exam. So for our exam, please use half. If you use any other multiplication for the exam, unfortunately, the final answer won't be correct. Okay, but in your future studies, forget about this course. For example, in future studies, you can decide. You are the one to decide what to put for my multiplication here of interquartile range. But anyway, in our course, we are trying to evaluate you by using this constant. Okay, so Q1 minus half of interquartile range. So you already calculated this one, you have this one, so easily you can find the final answer. Be careful, the value that you will find here should be for sure less than Q1. Why is that? Because you are subtracting something from Q1. That's obvious that when IQR is always positive, then of course the final answer here should be less than that value. So what about upper bound? We use this formula. So instead of minus, you have plus, because you should calculate something more than Q3. So the value that you will find here should be more than Q3 for sure. So please use these two formulas for your exam. I can't emphasize more. Okay, so in the item 6, we said that it should show outliers. That's the reason we define lower bound and upper bound not as minimum and maximum like in the lecture. So whenever we ask you about box plot which shows the outliers, it means that you should define lower bound and upper bound and show it in the plot. Now, if I want to understand whether we have outliers or not, so that's the way to check. I have my order data here, and I have my lower bound. My lower bound is 22.5. Do I have any value inside my order data which is less than 22.5? No. 35 is the smallest, and we don't have such a value. So from this side of the box plot, we don't have any outlier. But what about upper bound? Here it's 87.5. I can observe that there is one outlier here. 95 is bigger than upper bound, so 95 is an outlier. Now, how can I construct the box and whisker plot? Let me show you. The first thing to do is to draw this line. So first you have your axis. You should show all the values here at the end. So first thing first, show the median. Median is 42.5. Okay. Then show Q1 and Q3. Q1, draw this line and draw this line. So using a ruler, you can easily understand about the relative distance between them. So please use ruler. It doesn't necessarily need to be very accurate, but As much as I understand, for example, this distance is smaller than this distance, it's good enough for the exam, okay? Because if you show exactly with the same distance, it's problematic. And the values should be appeared here. So for sure, sorry, for sure, show the values here on your x-axis so that we understand which criteria corresponds to what. So Q1, Q2, and Q3. Q2 is median, as you know. So connect these lines together. So first you had these three vertical lines and you just connect it to show the box. So first you draw the box. The next thing to do is to draw the tail. So lower bound is 22.5. So on the left side, show us 22.5 like this. So this is the tail from the left side, or whisker. And on the right side, you can see that it is 87.5, and you show it like this. So the box and whisker plot is almost complete. The next thing to do, if we have an outlier, we can show it by excess like this. So this is an outlier, so show 95 is an outlier by excess. Sometimes we can have more than one outlier, sometimes we don't have any outliers. So if we have more, so we can show with other x's before and after that. But here we had only one, and I show with one x here for 95. Okay, guys, I hope now you are comfortable constructing box and whisker plot, and also pay attention to first items, practice with them, try to use correct formula, and if you have any questions about them, please let me know. See you guys.